So welcome to our next lecture on containerization. So today we are going to cover a very important and quite sophisticated topic of file and data exchange between container host and container themselves. So since this is very important and sometimes a bit misleading, I decided to provide you with some high level overview of different strategies how you can exchange data between these objects using Docker. So once again, imagine the sample machine learning pipeline. You have some data incoming to data prep component. Then you may have a separate paths for testing and training. And finally, evaluation component will provide us with some model evaluation statistics. So this is the very simple pipeline. Now, how it can be run on our computer? We are going to cover 4 different situations. First one will be just container serving us as a basic runtime. Second one, Docker container will host all the files within itself, and then very important communication aspects, Docker communicating with our local file system using technology called Docker bind. And finally, different components exchanging the data using a virtual Docker volume. Okay, so let's dive into. So as a starting point, as a ground basic, I'll show you the architecture where we run our pipeline locally without any Docker. So as you can see, we have 3 different objects here: local file system, Docker container, Docker volume, no Docker here. Everything runs on our local file system. So let's treat this as a baseline for our considerations. So now, next step. This is very typical usage of Docker. There is no file sync. Docker container provides us only with runtime environment. So libraries, packages, pandas, scikit-learn, torch, whatever we need for our computing is within a Docker container. And all the files are on our local file system. So we have completely no data exchange. So this is the first very typical usage of Docker containers. Very simple one, very efficient, but still, in some sense, very primitive. But as always, I tell you that if only it's enough for you, that's good. By the way, you have all the example codes and Docker files and README files in the corresponding folders in our course folder. Okay, so no worries. This is high level overview, but if you'd like to dive into details, you have everything in kind of the practice sessions on our file system. Okay, so container for runtime only. And now let's make something more sophisticated. We may have all the required files like Python scripts or data files with, for example, comma separated value files or some images, everything within the container without any sync with host. So I will show you the use case for that. Imagine that I would like to train my managers using my own environment. Yes, so I have some examples with Jupyter notebooks, with training data, everything in a Docker container. Okay, so I create such a container. I ask my students to run this container. Everything is opened on their local computers, but all the files are provided there. They type something into the Jupyter notebook, it reads the data from the container, saves the data to the container. Okay, so there is completely no data transfer to my local file system. If they kill the container, stop the container, everything is gone. Yes, so all files including data, CSV, change CSV, everything which is created during running the pipeline is stored in a Docker container. So there is no sync with host. So this is the next scenario. Okay. So now let's go to something a bit more fancy. We may use Docker bind mount to sync host data with the container data. In this setup, I need to run Docker container from a very specific folder in my computer, whether it's a Mac, or Linux, or Windows, whatever, yes. Then my Docker container reads the files from my local file system, does something with those files, and can save files to my local file system, yes. So it's like running Microsoft Word within a given folder of the computer. So I can read some data and write some data with local file system. So that you can do with bind mount. So you bind a local folder to your Docker container within the Docker run command. So you have full sync with the local file system during the pipeline run. Next scenario. And the final scenario, which will have two versions, single app and multiple apps. Sometimes you do not want to read or sync your data with the local file system because of many reasons. Yes? Your local file system serves only computing resources. That may be, for example, the virtual server in the cloud. What you want is to sync this data, like this is the first app, second app, etc., with the virtual Docker volume. Docker allows for that. This is so-called volume mount. It's not connected to a specific file system or folder. In fact, this is a virtual folder being created within this machine, yes, which is somewhere hidden in the variables. You can look for that in the tutorials, but still it's manageable. What is the typical use case? Sometimes you need to save data from one component and write this data from the second component, and you do not want to touch the local file system. Would like this structure to be possible to run on any server without specific call to a dedicated folder, because there are no folders of that type created. Yes, so you can do it that way. Volume mount. So you mount not a local file system, a local folder, but you mount something more abstract, which is the Docker volume. And that brings us to the most important aspect or strategy for large-scale deployment. Data exchange with volume mounts for multiple applications. Okay, later on I'm gonna show you how to work with multi-container apps, where each container may run on a different machine. Yes, so we can imagine those applications here are separate containers, applications on different containers running on different machines, and they can exchange the data also using the Docker volume mount. So this is the most typical scenario in large-scale deployment. So you have some Docker volume mounted, it stores data somewhere, it's being read, it's gonna be a data producer for this component. This component does some job, generates some other artifact, whether it's a data set or a model, and then later on it's passed to the Docker volume and read from this Docker volume to another component, etc., etc. So that most advanced scenario architecture for data exchange. As you can see, we completely do not touch local file systems in that way. And that architecture may be run, for example, using the Kubernetes, managed using with Kubeflow for machine learning, yes, and that works like that. So in that cases, if you would like to learn those solutions by yourself using bare metal installation, I strongly recommend you to start with extremely simple setups. The example setups are in my codes. You have precisely 2 or 3 different separate, very primitive functions just to test out the method because there are a lot of different configuration potential issues, challenges in, for example, Kubernetes setup, Kubeflow setup with data exchange protocols, etc., etc. So start with something simple. There is also another option to run such a pipelines, Kubeflow pipelines, KFP, on, for example, Google Kubernetes or Azure or Amazon Web Services. Yes, they have it much easier. They allow you to deploy it much easier way. So once again, we went through the most important, most typical scenarios. First one is the scenario where Docker serves only as the runtime. Second, where all the data are in the container, no sync to the local file system. Next, sync to the local file systems with bind mount, so you bind a local folder to the data. Data are exchanged between your running container and the local file system. And finally, 2 versions of syncing the data with the abstract Docker volume without touching the local file system. So these are the most typical scenarios, and if you'd like to learn them in more detail in practice, I warmly invite you to my examples in my folders. Thank you very much. Happy coding.